Find AB and PQ. Use the segments of chords theorem, which says that if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Using the segments of chords theorem, NB times NA equals NQ times NP. Substituting x for NB, x plus 6 for NA, x plus 1 for NQ, and x plus 4 for NP, gives x times the quantity x plus 6 equals the quantity x plus 1 times the quantity x plus 4, which simplifies to x squared plus 6x equals x squared plus 5x plus 4. Next, subtract x squared from each side to get 6x equals 5x plus 4. Then subtract 5x from each side to get x equals 4. Next, find AB and PQ by substitution. Notice that AB equals NB plus NA. So AB equals x plus the quantity x plus 6. Substituting 4 for x gives AB equals 4 plus 4 plus 6, or AB equals 14. Next, notice that PQ equals NQ plus NP. So PQ equals the quantity x plus 1 plus the quantity x plus 4. Substituting 4 for x gives PQ equals 4 plus 1 plus 4 plus 4, or PQ equals 13. So AB equals 14 and PQ equals 13. Find the value of x. Use the segments of secant's theorem, which says that if two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segments and its external segment. So using the segments of secant's theorem, RP times RQ equals RS times RT. Because RP equals 3, RQ equals 9 plus 3, RS equals 4, and RT equals x plus 4, 3 times the quantity 9 plus 3 equals 4 times the quantity x plus 4, which simplifies to 36 equals 4x plus 16. Subtracting 16 from each side gives 20 equals 4x. Dividing each side by 4 gives 5 equals x. So the value of x is 5. Find Wx. Use the segments of secant's and tangent's theorem, which says that if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So using the segments of secants and tangents theorem, wx squared equals xy times xz. Because wx equals x, xy equals 12, and xz equals 12 plus 15, x squared equals 12 times the quantity 12 plus 15, which simplifies to x squared equals 324. Taking the square root of each side gives x equals plus or minus the square root of 324, or x equals plus or minus 18. Use the positive solution because lengths cannot be negative. So x equals 18 and wx equals 18. Find the radius of the circle. Use the segments of secants and tangents theorem, which says that if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So using the segments of secants and tangents theorem, ut squared equals uv times uw. Because ut equals 3, uv equals 1, and uw equals 2r plus 1, 3 squared equals 1 times the quantity 2r plus 1, which simplifies to 9 equals 2r plus 1. Subtract 1 from each side to get 8 equals 2r. Then divide each side by 2 to get 4 equals r. So the radius of the circle is 4.